Hello, ladies and gentlemen, and we're back with another episode of this demo RPG. And I have a new camera angle, so enjoy seeing my long nose. And we're going to be working on the inventory. So, mainly what we're going to be doing here is adding a backpack to the player character. So they have a place to store their items, because that's sort of required. And I thought a lot about this. I thought about kind of making this global and letting whoever's programming the game instantiate them. And we might actually end up doing that. But for now, what we're going to do is just put a backpack on the player character because your character's got to be able to carry stuff. I think that makes sense. And this also allows for it to be a bit extensible in the way that like monsters and stuff are going to have backpacks too. So that later, in theory, when you loot them, you'll be able to dig through the backpack. So, all right. Well, we're first of all just going to, let's see, go to our player character here. And the main thing we want to do is just add a vector of items to the player character delegate. This player character delegate may be a just character delegate later. So it could potentially be used for any entity in the world, any living entity. So that's why we're going to extend it onto this. And we're just going to put it here as a vector of item star. Now it's important that these are item star because they're item pointers. If you make them actual items, you might end up accidentally copying the items a lot. And we don't really want that to happen with unique stuff because it'll call destructors and it'll reconstruct and it'll potentially make new unique IDs when we don't want it to. But if it's just a bunch of pointers in this vector, then the data is not really going to change. We might destroy and copy pointers and some, but that's kind of insignificant compared to the problems that we could have otherwise. All right, and we're just going to call this backpack for now. So there we go. We have a vector of items, or vector of item pointers rather. I hope that makes sense as we're trying to get into that. We're going to go down to where the player character is now, which is way down below here. Player character, there it is. So what we can do, this file is really big, and that's fine. I plan on cleaning it up later. These main classes, I'm just kind of going off on a side tangent here, just FYI. This whole set of stuff after the player, this whole set of stuff here is somewhat, it's specific to these classes, and it's going to have the level up trees and all that. So we might move this somewhere else later, and just to keep everything else cleaner. But for now, we're not going to worry about it too much, but I am going to collapse them for this episode so that when we're scrolling, it's easier to tell what things are. Of course, we had these macros. I'm going to put these macros somewhere else, like at the very top here. Just moving that around a little bit to make it look a little cleaner, and so that we can collapse it nicely and work with it. Now this depends on your IDE. Maybe you don't collapse, maybe you do. Sometimes it's nice to be able to do, but we're going to be just fixing this up a little bit and working with the backpack. We're going to need a few things. First of all, we're going to need a way, or we're going to need to change these functions that equip and use items to actually think about the inventory system. So I'm just kind of going through and collapsing things so you can see everything that we have here. Lots of getters. Now, I think it looks clean like this when you just have all your getters in one big chunk, and you can expand them out if you need to work with them. But that's your call. Some IDs have a hotkey to uncollapse and collapse, uncollapse. You can also navigate up here. So however you want to do it is fine. It's not too big of a deal, I guess is the point. But I just want to explain how I'm doing it because otherwise people might get a little confused. We might fix a few other things while we're at it. Like this get buff list that just calls get buff list, and some of these that just call the same thing. We might refactor those, but for now we're just going to leave it. But I've noticed and kind of tweaked a lot of things in the meantime while figuring out the inventory, and that tends to happen. So we're going to make a new function here. Let's see, in the modifiers. So we got this modifier set. I'm just kind of, keeping these nice getters here, all the modifiers here, and we'll get rid of these comments now because we're not going to need them. So what we're going to add here is a function that is just called move to inventory. And we'll do a Boolean again to see if it's succeeded or not. Move to backpack rather. And this is going to, of course, take the item to move. A pointer to it. Item to move. And let's go ahead and work this function out. So first of all, we want to do the standard checks we were doing before. Just make sure the pointer is not null. If it is, we just return. So we'll just copy that down. Not only the item needs to be not null, but the data it has also has to be not null. So there might be a way to clean up those checks to not do them all the time every time we call these, but we'll think about that a little later if we end up doing some refactoring. The main thing we need to do is just call backpack, the PC class is backpack, and just push this item in it. So backpack dot pushback item to move. Now, if we think about this, what is going to happen here is it's just going to move this pointer, or it's going to push back the pointer, which, depending on your version of C++, and it might do different things. It might copy it, or it might copy the pointer, which is okay. We just need to think about memory management there, because if we move something to the backpack, we don't necessarily want anything else to manage it from there. It should now be managed specifically by the backpack, and that's something we just need to consider, is who controls this memory. Because if we're passing around pointers to it, if one person modifies it, the actual data it's pointing to, it's going to essentially modify everywhere. And that can be intended or not intended. So just something to keep in mind as we go here. So if we get to this state, we just return true. And we're just going to keep it that simple for now. We literally just pass it in there. It puts it in the backpack. Now, there's only very few ways we can mess with the backpack right now. Right now, it's literally just this function. But I think what we actually want to do is make this function private, because we don't want anyone to call it yet. So let's just go down here and just put private right here. These deleted constructors, it really doesn't matter if they're public or private. We can leave them private, so it's fine. But we want this to be private because we don't want anyone to call this just yet. It's going to be used internally through this equip or use function. No, let's make it public. Okay, because I guess, we want to be able to loot stuff and move it, but ideally this might actually happen through an item manager so that we can be more careful with that pointer. It's kind of what I was thinking, but for now, we will leave it public, but it might change in a later episode. Okay, so now let's refactor equip, and let's refactor this use to more properly use, or to move stuff. So what's going to happen now with these move, or this equip, is we used to just delete what was in the old slot. Like if you equipped an item, like say if you equipped a helmet and then you equipped another helmet, it would just delete the old one and equip the new one. Now we want to take that old one and put it into the inventory. So this delete, right where we have this to do here, we're just gonna call move to backpack. Oops. And then on that item. So this is a little tricky here. We have to think about this carefully. Because the thing is, this actual equipped armor, it's not the item to equip, it's the data in the item to equip. Right here we get item.data. But we have to move the old item basically. So we need a way to get that, and that's where things are going to get a little tricky, and we might have to do some refactoring. Okay, I might have had a bug in the way I kind of preset this code, so we're going to fix it on the fly here. All right, let's walk through this. All right, so just to make sure we understand it, say we call equip. The first time, it's going to be fine. There's going to be nothing equipped. It's just going to equip it. But what happens to the item exactly? And who's managing it now? Does anyone else have access to the pointer still? Well, whoever called this function still does. So that's not exactly what we intended. Yeah, this gets messy at this point because the item manager doesn't really work with this the way it is. We can create armor. If we go to our item manager, we can create stuff. But this, once it returns this pointer, it doesn't do anything else with it. It's no longer in control of it. And we know that if one of these items goes out of scope, it will actually delete the data of this item delegate. And same with all these weapons. If they go out of scope, they're supposed to delete any pointers they have. These ones don't have any pointers, so they're handled. But this item star does get deleted. So we don't want to delete it because then that's going to mess up stuff. And if we're moving items around, we know that items right now have unique slots or unique, if we look at equipment delegate here, they have unique IDs. So if we say, decide, we're not going to move it around, we're just going to like create a new one with that data, it would create a new unique ID, and we don't want that to happen. So we need to think about that. So the reality is it would probably make a lot more sense to have this item manager handle more stuff. That way we can carefully keep track of these items just a little bit better. So I think it makes sense to take these equip and use item and move back to backpack to just take these completely out of here. Now let's go ahead and undo this move to backpack. We're going to do just a hot copy and paste here. All right, so let's go ahead and just take all this, and I'm going to do a cut. Just Control X. And we're going to go over to the item manager, and we're going to paste them in here. Now we're going to have to fix these up, so let's start from the top. First of all, these are all going to be static. So we can just put static in front of all of them. And they need to know where the item is going. So this needs access to a character that is going to get the item equipped. So we need to pass in a character. And what do we need here? Well, let's look at how we're instantiating our guy. We need a player character. All right, so we need to pass in here player character. And we can do it in multiple ways. We could do it as a reference, or we could do it as a pointer. And really either are okay. We just, let's just do it as a pointer for now. All right, so we'll go player character. We just need to give it a name here. We'll just call it, P character or P care. So now you can't just do care. Yeah, P care is fine. Sounds a little weird, but we're going to do that for all of these. So when you use an item, you got to say who it's getting used on, and that's going to go off of their inventory. So there's more functionality we're going to need to build up here, basically. So if we're going to have this move to item, move it to a player character's item, we're going to have use and equip. So this will essentially allow us to use items from anywhere, but this brings up sort of another issue. Well, I guess it's not too big of an issue because, well, we just need to make sure it doesn't get duped anywhere or exist in two places or something like that. Or if it does, it needs to be specifically intended, like if it's on a hotbar or something and the hotbar is supposed to share a slot, then they should both share the same pointer. But if not, then, we don't necessarily want to do that. So since we're taking a pointer to the item, it's going to work off its data. No matter where that item is, it should be okay. But we might need to update that later too, to consider which backpack it's coming out of. But for now, there's only going to be one essentially, so it should be okay. Well, I guess there's kind of two if you think about it. There's the one the player character has, sure. But then there's like the global universe one, which right now is actually just our main. Because in our main, we're just creating items. And this is essentially our world space. So items, the memory we're managing in this main is kind of our world space. So essentially we kind of have two inventories. One that's like, this is like God mode, where we can do whatever we want with items. And then we're going to have the player's backpack that's got to be more carefully managed. But we also need to consider this stuff here too, and what's going on with it, and where it's in, and what these pointers are doing. Because if we put one of these items into a player character's backpack, we shouldn't mess with it globally anymore. Or maybe if it's a quest item, maybe we should. So just things to think about. This gets really complicated when you try to wrap your head around all the different scenarios of what can happen. And it's not always super easy to develop. Most people just, well, not many people code this from scratch, is what I'm trying to say. Most people just grab a little add-on for whatever and just use the add-on because it's easier that way, and it's probably more optimized. We're not really going for optimization right now, although it's not going to be too bad using pointers. It's going to be pretty decently optimized just by innate design. Now with all that theory crafting out of the way, let's start with this move to backpack method. So first things first, item manager is not going to have access to private stuff in this PC class, because this is going to be like P character, PC class, and then backpack, pushback. It might be dot here. Yeah, dot backpack. There it is. Oh, okay, that's right. But the thing is, PC class is private. So you may have learned from a couple previous episodes, there's ways around this. Since this is private, it does make sense for the item manager to be able to mess with the player character. So it's okay to make it a friend. Friend, class, item manager. There we go. Now only the functions in this item manager class can touch this stuff. So that is good. because that's what we intend, and then we can design our memory management of this backpack stuff right in here as we go. And I'm probably going to change these functions around as we go. Like, let's capitalize this stuff first of all. And we are just going to keep doing compiler error development. That's basically what we've been doing most of the time. So this should in theory work just fine. We got an item, take the player character, move it to its backpack. And now this doesn't consider whoever passed in this item to move. It doesn't consider what they're doing with this pointer. They could still have control of it. We essentially both have control over it at this point, which is sort of dangerous. And it also doesn't consider if this player character is null, which it could be. So let's just check that. If not the character, we'll just return false. And we might even be able to clean this up a little bit by just doing something like this. We'll just OR all of these. We probably want to do it in this order. Because if I remember correctly, these operate, when you have stuff in parentheses, it tends to operate from right to left. So first we want to check that the item exists, and then that the data, and then that the character exists. Or maybe we want to check the character first before even deciding the item. So in that case, we should put it on the right. Now this doesn't matter a ton, but it just means we have to check less things if the thing that gets checked first might trigger the false on this OR. Because if it has to go through the things that are most likely not going to be null, then it's going to check more things. And it can affect the efficiency of your code. So something to keep in mind if your checks are expensive, which these are rather cheap, but if you're doing something like calling a function here that returns a true or false, it's important to put the one that's most likely to fail on the right side. I believe it's the right side. Correct me if I'm wrong. All right, so there we go. We made that a lot less lines of code, basically, and we still do what we intend there. And returns true if it succeeds. And let's go ahead and fix up these other functions. So equip now. Now we need to think about this. Okay, we'll do the same check. We'll just do this check. And let's put this at the top. Looks good. It's now item to equip, not item to move. And we're still going to do the same stuff here. When we go to equip, let's check if it's armor. If it is armor, then we go ahead and get that slot and see if there's something currently equipped in that slot. So we got to check that on the character here, like so. Now that we're using this style function. And if so, we want to move the old one, the old item, into the backpack. However, this is the get data part, this currently equipped armor. So that's kind of the problem we actually run into here. So we need to think about that. Now there's a couple different ways we could do this. We could make a move constructor, or we could make, let me think about this. Or the other thing we could do is in our character, we could be saving these references of all these equipped things. Now that's probably going to make more sense in the long run. And it's just going to require a little extra thought. Because if we think about it, these are just equipment delegates. They're not items. And what they probably need to be is actual items. Because if we look at this, it would have to be an item delegate and then instantiated down through equipment and then armor to have all this item stuff available. Because right now it doesn't have this item stuff available. I think I'm saying that right. Okay, then we no longer want the player manager to manage items. It's going to be done by the item manager specifically. Okay, we might accidentally introduce some bugs here, but I think what we need to do here essentially is turn these equipment delegates into just plain old items. All right, and this will make more sense shortly because basically we need to store this entire thing. Otherwise, it's not going to go so well eventually, because what happens when we try to swap is, we're looking at only this data, but we're not holding a reference to the item to equip. We're only holding the data in the slot. So we need to actually know what item it is to swap, basically. I hope that makes sense. But it's essentially going to be the same for the most part, and I'll explain and we'll walk through it. So this is all still the same. We still do want to know if this data is armor or not, because we don't want them to equip a potion, or these still should fail. So this will be the same. But, okay, and this getting the slot will be the same. But let's look at the case where we're equipping fresh stuff. This one here is if the current slot is filled. Then we'll do a move old item to backpack to do here. But let's look at this case here where it's a fresh slot and nothing's equipped. That's this else right here. We don't want to call this on armor. We want to call this on item to equip now, because this equipped armor slot is now this item to equip. This might not have forward populated just yet, but that is what it is. Oh, it's because we gotta reference it from the character. So these now all should have this going on. All right, we'll get to the weapon in a second. It'll essentially be the same, just with weapon. All right, so now what this means is this equipped armor slot is actually going to store the reference to the item, so we can move that into the backpack as we want. So we can literally just call move to backpack, and we can call it on the item. Well, we can call it on the old slot, which is this slot here. And it's already a pointer, and we need the character for that function to work with. So this function, it'll just call this one here, and it'll move the stuff, check all the references, and just, you know, put it on its list, its backpack list. And then it's gonna equip the new one. So move old item to backpack, and then it's gonna equip the new item to equip, and that should take care of it. And we're essentially going to do the same thing down here with weapon. Let's just clean up this code and make it as concise as possible. And I don't think we really need comments in this case. We might put one at the very top here, like right here. Equips a weapon or armor and returns true. Returns false. All right, that should sort out the comment. And yeah, tells you what it does if there was a previous slot. And that's a fine comment. So now we just got to work up this weapon one. And we're just going to copy this code here and paste it, because it is essentially the same. We just need to change all these mentions of armor to weapon, and all these mentions of equipped armor to equipped weapon. Little copy paste action, and this will go quickly. Oh, we forgot to bring down what? Oh, I spelled this wrong. Equipped weapons is plural. So we don't say armors, but we do say weapons. So I don't know, those could be renamed, but it's fine as long as we get the point. So that should work. And it should work fine because it's literally only going to try with the weapons and armor. Anything else you try to equip is just going to return false. And that should be okay. So equip should be done. Let's check out this use function. We're going to do the same initial base case check here. Except it's now item to use rather than item to equip. And we're going to do the same kind of cast check to see if the data is a potion or not. And if it is a potion, we'll try to do some stuff. This apply buff is part of the PC character. So we will do it like so. The potion has a buff. We will apply it. And same logic here, but we just want to make sure we are calling this on the character. Don't use the potion if they're full health and it doesn't have a buff. And the potion doesn't have a buff. Do a little HP increase and reduce the potion quantity. And now here's where it gets a little different. If the potion quantity is 0, it just currently calls delete potion. That's going to leave some dangling pointers unless we make sure it cleans up any references, any pointers pointing to that data, because while this will delete the data, the pointer is still going to exist and we're going to get an error and in our code at runtime probably. So that's not good. So what do we want to do here? Let's think about this for a second. Well, we probably want a little function that anytime a potion is reduced to 0, yeah, sure, we set it to null. We delete it and set it to null, but also we need to clean up the user's backpack or inventory of potions. So that's just something we need to think about. Now we could call this anytime we call any function that works with the backpack, but really we only need to call it when something is being deleted. And I think the way we're going to do this is we're going to mark things for deletion. That way on the next game update, the next time it could process things, it will delete anything that's marked for deletion. So rather than just do it instantly, we'll mark it. So we're going to go potion, which is an item, and just mark for deletion. We'll make a function for this. Mark for deletion. Now, our potion is an item, or an item delegate, so we can put this all the way at the top, because in theory, any item could be deleted. And let's just put it in protected here, or well, let's make a function, void mark for deletion, that you can just call. And let's make a protected variable. That's a bool. We'll make it underscore, or well, no underscore, just marked for deletion. We'll start it out as false. And we just want to change that to true. Marked for deletion equals true. So now we can call this function and it'll mark for deletion. But what's the actual delete going to do? Well, it's basically going to clean up an item entirely if it's marked for deletion. This will also allow you to delete junk out of your inventory, so we can use this later if we want a little thing that says, all right, I picked up all this scrap that I can't even hardly sell or something like that in our game, and you just want to get rid of it. You should be able to just delete it, or at least drop it. For now, we're just going to do delete, but later we might change that to, maybe we'll give an option for destroy or drop. It just depends on the game. Some games say you can only drop and then it disappears if it sits in the world for too long. So we just need to make a decision, and we're going to just decide to delete things only, just for ease of use. So in this case, what we want to do is we want to have a way to go through these items and clean them up, basically. It might even make sense to put that function in here, but since it has, well, yeah, let's do it actually in here. So because if it's in the delegate, then it's like this actual data here. It's going to exist in this private data. We don't necessarily want that. We want it to handle somewhere else. So we'll do the marked for deletion in the actual item. That way it doesn't, that way it can be like more public. And we still have this friend class item manager. So only the item manager could access this Boolean of whether it's marked for deletion or not. Now we need to think about, is that something we intend? Because ultimately, I think no. I think we're going to make that public for now. If it's public, we don't even really need this function. Let's do this a slightly different way. Okay, so let's leave this Boolean in private, and only the item manager can set it. That way only the item manager can change this marked for deletion. And then let's just do a get. That way anyone can check if it's marked for deletion. Get marked for deletion. Sure. I'm doing this camel case for public, these underscored version for private. Kind of mixing it up a little bit, but I tend to do something like that usually just to be able to tell, rather than putting a P or, something like that. This way, not just any random person can mark stuff for deletion. It has to be done through the item manager, and we can do it right here. Marked. So this we also need to think about. Just in the same way we had to refactor this to equip the actual item and not just the data. We also need to do the same thing here. This potion here is just the data. We need to actually make it this item to use. And also, if we end up marking something, we could just go ahead, well, until we have a core game loop that might check this every so often, we probably want to just do it anytime we mark something new for deletion, is just call cleanup inventory. Inventory. Or cleanup backpack, rather. And this is a function that can exist on the character. So we can just call it on this character since we have a reference to it here. It's definitely something that's going to be refactored later, I think. But let's go ahead and go to the player character and just make a cleanup function somewhere. So the item manager has access to private stuff. Let's give it a function for cleanup backpack here. We could even put this in the delegate where we have the actual backpack. I guess it's debatable how you want to do it. It would work fine either way. Let's make a hot change. Let's take this backpack out of the player character delegate and just put it in the player character class as a private vector of items. It's going to really work the same way, either way. But essentially all we want to do with this cleanup backpack function is just go through and delete any data and remove it from the backpack. And we already know that these items, they've got a destructor that's going to destroy their data. So as long as we destroy this item or call delete on it, or free, however you want to do it, it's going to delete all the internal stuff. So we just need to call that. And there's an algorithm we're going to use. So we could write this manually, but since we're already using vector, let's go ahead and use algorithm, because you can imagine how we'd have to do it. We'd basically have to go through the vector, delete the data, and then remove it. But there's some functionality to do this. We just need to get the iterator of any of them that are marked for deletion. And we can do that. I'll walk through all this. We just need to get the iterator, right? So we're going to make an auto. We'll call this toRemove. And we're going to call a function standard remove if. That exists in that algorithm header. So what we need here is a iterator where it begins and where it ends. And we just want that vector. So we just go backpack.begin. That's the beginning of the vector. And we want to search all the way through backpack.end. And then we want the case here at the end. And we're going to use something that you may not have seen yet. We're going to use a lambda. Now all the lambda really is an in-place function. And we just want this function to return true or false. We want it to return true. The item is marked for deletion. And we want it to return false otherwise. That way we can get all the stuff to remove. And the way you make lambdas is with square brackets, parentheses, and then the squiggly brackets. And there's a lambda. So I'm going to just break the end of this remove if down here so we can see what we're working with. So this here is a function, and we need to make sure it returns. So this is optional. If you just have return true here, for example, it'll return true all the time. Okay, we need that there to end the remove if. So that's returning true all the time. Oh my goodness, I've made this small the whole time. Here we go. Let's make it bigger now. But we don't want it to return true all the time. You can also make this lambda. Let's break this lambda to a new line. But just keep in mind, it's the last part of this toRemove. So you can specify right here that it returns a Boolean like so after these parentheses. But also, it's implied that what it returns, so you don't necessarily have to have this here. All right. But we actually just want to return, well, we need to operate on something. So it needs to take something in. In this case, we're taking in const item, whatever this backpack is, basically. It's an item star. So that's what we're taking in to this lambda. And we'll just call it I for item, sure. And we want to return I marked for deletion. Or is marked. What do we name this? Get marked for deletion. So this will return true if it is. Now this is complaining about something. What's this we're complaining about? Oh, it's const. Okay, gotcha. We actually want this to be const as well. Constable. There. Now it's going to be happy. Just wants everything to match up. I think. Oh, oops. One other thing we want to do here. This const is kind of optional here. Probably going to be returning a copy anyway, but we want this function to be const, which basically just says this function does not change anything in this item class. And that has to be like that. Oops, I keep going to the wrong one, because this here is const. So it just wants it to match up to say, hey, the item's const. The function you're calling should be const too, just to make sure you're actually not changing anything. So kind of a nice little warning there. And this const is a little more optional at this point. I think it'll be fine either way. All right, so that'll get an iterator of the stuff to remove. And then we just want to call erase on this backpack, basically. Erase, which is another function in algorithm, or actually it's in vector. And we need to call it on the iterator that we want to erase. There we go. So this remove if and erase, they're kind of black boxes, but you can go look them up. You can Google search them, or if you're in a, you can go to the header file. It's F12, or you can follow however you do it on your IDE, but I just hit F12, and it goes straight to the function. So this is the actual function that it's calling. As you see, it takes a forward iterator, first and a last, and then a predicate, which basically wants a true or false. And it runs through, and you can walk through all this and see what it does. And you can do the same thing for erase if you want to see what that is. Check that out. Now you got to make sure sometimes Visual Studio will go to a function that's like somewhat the wrong version, but this seems to be correct. See, it wants a constant iterator where. So I guess if we're being very technical, we should probably make all these iterators const. This auto might work for that. Yeah, this should be fine. If we put const here, does it make any difference? No, it doesn't seem to. It seems fine. So that will, okay. So basically all that's going to end up doing is anytime we call cleanup backpack, something's marked for deletion, it's going to call erase on it. And erase should call delete, I believe. Now we probably want to test this just to make sure. But if we look at from this bracket to this bracket, that's the entire function. So we could, if we wanted to, we could walk through all of this very carefully and just make sure it's calling something. It looks like we do call destroy here. And I'm not entirely sure what all of this does, but I think it'll work fine on a pointer. We should probably do a little Google search and make sure. Okay, so I typed into Google, just calling erase on a vector of pointers. Does it call delete properly? C++. And it looks like we got some answers here. And we probably want to just review these and just make sure we're doing things right. Make sure we're not getting a memory leak. Looks like they're doing it a little differently here. Let's search erase. No, they don't even talk about erase here. We're specifically talking about erase. Now, I kind of warned against some of these, but sometimes it doesn't hurt to read them because generally it's decently vetted. Okay, looks like we could even put this remove if inside the, yeah, just right inside erase because erase has an overload. So let's actually do this. Okay, little thing popping up there is kind of annoying. All right, but does this actually delete the pointer? If they're unique pointers, it will, sure. But if they're not unique pointers, it probably isn't. So we're probably going to have a memory leak. See, here we go. Standard remove. Well, you end up with a memory leak. So we are probably leaking memory here. And the easiest fix to this is probably to make those unique pointers. But what we actually want to do is delete the pointer, basically, as we go through. All right. And we can do that. We can actually do that like right here. In this here. And it's going to look a little odd. Maybe there's more efficient. We can say if marked for deletion. So we're now getting logic inside our lambda. Might look a little weird to some of you, but I'm kind of used to these at this point. Get some practice with lambdas. I have a video on lambdas. If you search my channel and just search like all about lambdas, I have a video that essentially goes over everything about lambdas. That's probably a pretty good watch if you're not used to them. And yeah, if it's marked for deletion, we want to call delete on that item. Let's make sure we do this right. Okay, so this isn't exactly going to work how we think, but it looks like the answer here is stable partition. So that's pretty interesting. And with stable partition, we need to reverse the predicate. So it's kind of the same thing, except stable partition here. And we're not going to do this delete yet. Now I should probably explain a little bit more about what this remove if and stable partition here in this case does. It does move around things in the inventory some, because it sorts things so that everything that's being deleted is at the end. That's why you only need one iterator, because it's from that to the end that it deletes. So it puts all the stuff to keep at the front and all the stuff after that or after this iterator and to the end gets removed. Now you can read more about stable partition. I'm not going to explain it totally, but since we're doing these raw pointers, that's why we have to do it. So let's keep cleaning this up and then we'll run a few tests and we'll probably be about done here. All right. Now let's see here. Our predicate here is going to be the same thing. except it's going to be a not get marked for deletion. Just because we're doing stable partition, we need to do it backwards. And then after calling that, so we get it sorted and that stuff, and then we need to go and do a for each. I'm just going to do a little copy paste here and then fix it for our code. To remove, this is backpack.end, and then we need to call delete on it like so. And that should work, because we'll be calling delete on this item, which is in turn going to call delete on the data with this destructor. So that should clean up everything properly. And then we need to do one more thing. So this essentially is going to delete all the data inside of it and stuff, but it's going to leave this pointer dangling until we call the final erase, which I'll just copy over here. Backpack.erase from this to remove to the end of the backpack. There we go. So that's going to be our proper cleanup. So yeah, that's all explained here. I'll leave a link to this down below. But if I got this slightly wrong, you are totally welcome to correct it on GitHub. Another solution is to delete the pointers and then set them to null pointer and then do remove on all the null pointer. Okay, so yeah, we could do something like that too. But this is fine. We get to practice with stable partition, for each, and erase. And the next thing to do is just test this and make sure it actually does what we intend. So cleanup backpack is essentially going to be sort of a black box function, because it's going to be hidden away privately in the end. And if it's messed up, we just need to go correct it. But essentially, once this works correctly, we probably never want to touch it again, and we just call it when needed, and that's it. So that's the way things are with black box functions, but they need well tested. They need to be well tested. All right, so we're pretty much ready to start testing out these items and see if what happens when we equip multiple helms, see if one goes to the inventory and move potions to the inventory, that sort of thing. There's one thing I want to do real quick, and that's just go to these core stats and just make a new constructor that is just a base case constructor, because right now we have this, but we want to also just be able to like in constructors, if it doesn't have any stats or if they're all 0, we just want to be able to call this. That'll be kind of nice. And we also want one that just sets them all. Currently we had overloaded some operators, which is fine, but we need a few more constructors just to help us out a little bit. So there's also another one that just takes each stat type and sets it. And that's just going to help us going forward a little bit. So close that. And now we can go to our main and start testing stuff out. So let's do this. All right. First of all, let's see. Sure, we'll create our warrior. First thing, that's fine. And now we want to do these core stats and all this equip stuff a little differently. In fact, we don't want to have these in their own scope anymore, because this is kind of, we're going to like have a little global management for the moment. Now, essentially, I will reiterate that this is basically a big test class. And we want this to be armor. So yeah, we can use some of these constructors here if we need to that we made. All right. 0, 5, 3. Okay. So we can just do these in place for some of these. It's going to save us a little place, a little, I don't know what I'm trying to say, a little room, I guess. And we don't want to necessarily equip it yet, so let's just delete all that code. We're going to do another create armor, and this one's also going to have some core stats. You know, let's make, we got full plate. Let's make leather armor, and we'll just try it. We'll test this out with a couple pieces of armor. So this is plain leather armor. And we'll lower the stats a little bit. I got 2 and a 1. And we need to make sure it's the right slot here, both chests. Because this way, if we equip one and equip the other, the one that we originally equipped should go into our inventory. So let's just test that out. We'll make our sword here too. Sure, why not? Sword has no stats at all, but it does have the damage. So that's kind of a different case. Now we haven't actually equipped anything yet. We're saying all our character stuff here, including what's in their slots. I guess we'll leave all that code there. It's kind of, you know, we've seen it in every episode. It's kind of long. We've got those 3 items. Let's try moving them to the inventory. All right, let's just try equipping them. So we just go p1.equip. Oh, we have a get. We can't call equip anymore. We actually need to use the item manager. Like we changed it. Item manager, equip, and we need to pass it the player, well, the item, then the player. So let's first equip this full plate, and then it needs the character. Now, obviously here, the character is not a pointer, so we can't just, it wants a pointer. So we need to use a reference to give it a pointer. And that's it. And if we made this a pointer and instantiated it as that, we could just pass it, but this will be fine. Okay, so that should equip the full plate, and then we can equip the leather armor. And what should happen is, once it equips the leather armor, it should put this full plate into our inventory, and we'll check that later down the line. And let's also just equip this longsword just to make sure it equips properly. Equip longsword to player 1. And we're looking pretty good here. So we had also this use item that got changed too. It's now item manager use, and then we need the character to use it on. So we'll leave that in here just to make sure it all works too. Leave a few cout statements. And also at the very bottom here, we need to keep track of the inventory. So we create a healing potion and we use a healing potion, but we didn't actually put it in the inventory. So we need to actually put this in the inventory. Let's do that. And you could essentially do the same thing with equipment on the fly. Let's, for example, just make some other sword, like a short sword, or no, we'll make it hand axe. We'll call it rusty hand axe. And we'll give it some weak damage, like 1 or 2 to 4, sure. I believe here we also need to specify, no, the two-handed defaults false, so that's fine. Okay, now we just need a way to say what's actually in the what the items are. So of course we're going to do this in some graphical interface eventually, but for now let's just do a for loop and go through each item. However, the thing is, it's going to be messy because we're going to have to call get data, and then on this data we're going to have to see what it is and cast it and do all kinds of stuff. So we're going to put in a few little tricks here for now of some overloaded operators that just help us with the cout manager. So we're going to just include IOStream for testing, and we'll eventually remove it. And essentially what we want to do here, I'm just going to copy this over, but I'll explain it, is we want to make a friend operator output stream. And I wrote this live on stream at some point, I think. So I explained it at that point, but I need to explain it again, I'm sure. Basically all this does is if you use cout and pipe it this, it already knows about the stream because of the operator, but you need to pass it an item. And when you pass it an item, it checks if it's armor. If it's armor, it spits out this stuff here. If it ends up being a weapon, it spits out this stuff. If it ends up being a potion, it spits out this stuff. So it's basically a way to help out. And in any case, yeah, we return all the stuff we're spitting out. So it's just going to give us some information about it, as you can see here. So this way, in our main here, we can just iterate through that backpack. But we don't have a way to get to the backpack, because if we look at player character, backpack is private. So we're just going to work with a copy right now. So somewhere near where we have get ability list and get buff list, let's also make a vector of this. Let's just get item list. And these are not efficient. They're making copies. They're pretty ugly, but it's fine for now. It's a pretty small case until the game gets big anyway. And all we're going to do here is return backpack. Maybe this should actually be like get backpack list or something. Did I spell backpack wrong? Yeah, I did. All right, so it returns the backpack, and this is going to be a copy return. If we want to be like super safe, we could make these const just to make sure no one messes with them. And in reality, all of these gets should be const. So let's just go ahead and clean that up real quick while we're at it. Do some serious const pasting. Const pasting, it almost sounds like something else. It is generally good practice to make all this stuff const that are just getters, because it basically disallows modifying anything that you're returning, which can matter. And it's also going to help you keep your code clean, because it's going to make sure that anything you're returning is not being modified. So, okay. We have a few ambiguous things here, like this equipped armor. We now need it to be get data, because as we changed it a bit ago, yeah, I know it, this has been, we need to update this code because of how we updated how these equipped armors are. Basically, we need to be able to tell that it's armor, and we already know that it is. We just need to basically check if it's null or not, because these slots can be null. So that's something that's got to change for printing out our character class. I'll go ahead and do that real quick. All right, well, to redo these, we have to do some ugly casting. Well, we know it's armor, so this should not fail the cast, but without it being tested, it could. However, we have this other problem where it says it's inaccessible, or the data is, and we can't, of course, call get data. Otherwise, it's going to give us some errors with const and say it can't cast const away. So we need to actually have access to data. And to do that, I guess we're just going to have to apply the quick hack of making it a friend again, which I didn't really want to do, but we're going to put it back in here for now. Otherwise, we're going to be rewriting a lot of functions, but in reality, we do want to do this in a smarter way in the long run. So we might do that down the long line, but for now, I just want to get it working. So we'll get that cast going and then just get the armor from it. And this shouldn't even try to do this if there's nothing equipped. So this should be okay to do every time. And we're essentially going to do the same thing for all these other little red underscores, is we just got to do this cast. So I'm just going to copy this right here and we'll straighten it out on all these. Okay, there it is on the get strength from weapons. We also want to get strength from armor. So it's gonna, hey, this is just in case they have magical stuff. I think we did this a long time ago in one of the episodes, but this should be strength here. Okay, because yeah, this is in the get strength. Yeah, we just want to total up the strength we might be getting from magical armor and magical weapons and put it all together. Pretty standard stuff there, but we're just going to have to write all these like this for now. And while it is a bit tedious, we should be able to knock it out pretty quickly with some copy pasta action. I'm literally just going down the line, doing this cast, changing it to the stat it's supposed to be. And then we'll do the same thing for strength here in a second. So basically on all these get total whatever it is after equipped armor, we do this armor cast, making sure it's getting the right thing. Looks like we got all those, and we just need to do the same thing for weapons. So I'm going to go up to this get total strength. Let's start here, and we already did this one. Let's get the intellect from weapons. So this brings up a good point of something I can say while we're stepping through this, because this is kind of mindless code here. Just make sure we get it all correctly. A lot of the points of the things you design and design in an intelligent way is basically so that when you refactor or add something later, it doesn't become a huge pain. It's nice to be able to design in a way where you can change it in one area and it will dynamically change all your code without you having to do this sort of stuff. So often a sign that it needs refactored to be done in a smarter way is if one thing changes, you got to go through and change every function. That's usually a sign that you messed something up in your design. But I have sort of mixed opinions about that, because that's not necessarily true. Like sometimes you just need to get it done, and trying to refactor it will take way longer than fixing it. So you can use your own discretion, but if it becomes way tedious, then for sure you're probably wanting to refactor. All right, we got one more red mark over here. Let's see if we can find it. What is this? I'll just final equipped weapon here. Okay, grab that code, put the cast in there. There we go. I don't see any more red dots over here, but I think we're good. I think we've got everything we need. So we're going to go back to our main and just finish this loop. Let's get the inventory list. Auto inventory equals p1.get backpack list. And we'll just iterate through this with some auto. And we can use the beauty of that overloaded function to just do that, and it should spit out all the details about it. And let's just separate it with commas. And maybe we'll say, before we actually do this, inventory. So it'll say inventory, and then it'll just list everything. All right, so I think we're good here. What we should see is we should see that the character has the longsword and leather armor equipped, and we should see that they have a heal potion, full plate, and a rusty hand axe in their inventory. Oh, let's actually put this into their inventory with move to backpack here. Rusty hand axe. You know what? We could even call this create weapon right inside, like here. That would actually work. So we don't necessarily need to store it. We're just going to move it to the backpack right away. We can just create it like so. So just another little trick there. All right, but I do want to try using things out of the backpack and see if that works, because we're making 3 of them. When we actually see the backpack list, we should see a quantity 3 because 1 got used. So let's just make sure that works. All right, here we go. Would you believe that we got no compiler errors, and I did not cut this? We just did all that with no compiler errors. Amazing. Okay, so let's analyze a little bit. This didn't build. I lied. We have compiler errors. We have some build tools, platform toolset problem. What am I using here? I'm using Visual Studio 2019. Oops. This is all targeted to 2022. So let's just exit here. And I'm going to reopen this solution. Open with Visual Studio 2022. And hey, we got our old theme back. So I guess ignore my rant about the whole theme thing earlier because it's kind of not relevant actually. I accidentally opened it with the wrong version. All right, let's see if we build this. So that wasn't a build error technically, but we do have some here. Let's have a look. We accidentally typed an F in here. It's not supposed to be there. Backpack is now part of the character. So I'm just got to correct that. And that seems to be it. Very small things. And we built successfully. Let's go ahead and hit play. Oh, it went. Looks like we got an exception thrown where PC class, something about this.pc class was null pointer. And that's at this get equipped armor at. So yeah, that's a thing. We want to return. We want to make sure this isn't null. A valid point. So let's just have a look at where we're calling this. Get equipped armor at. And it's calling right here in this cast. Just where we're checking our armor list. So what's going on here? It's getting the data. It's returning a dynamic cast. This should fail. Okay, so I guess here we want to, we just want to do a check. If equipped armor at I, if not equipped, we want to return a null pointer, or we could return it if it's null. Let's just see what that does. All right, let's give this a run. So we might have had a little logic errors here. Undeclared equipped. So I spelled equipped wrong. Let's try that again. And now we get it at the weapon. Okay, because the way we changed these equipped armor and weapons, yeah, it makes sense that now we need to also make sure this isn't null ahead of time. Because as long as this isn't null, these equipped armors, then the data, there should be something in the data. But yeah, that's it. All right, we're getting some strange things happening on the inventory here. We can analyze this here in a second. But let's just make sure everything else looks okay. Let's look at the level 2 warrior right here. It shows that, well, most of the stuff looks fine. Armor. He's got the leather armor on. He's got a longsword equipped. Health potion seems to be working fine. Inventory, he's holding 3 items, except that it's showing the pointers. So what does that mean if it's showing the pointers? Well, it's not calling the overload. That's one thing for sure. So we're looking down here. This is not calling the overload. Because these inventory pieces are pointers, we need to dereference them to get the actual item, because it's the actual item that, oh, It doesn't work. Yeah, we're basically getting a pointer that lives in the vector with that. So to get the actual item, we need to dereference it, and then it should say the stuff. Yep, it does. Okay, cool. Let's do it this way. Yep. Seems to be doing okay. Okay, so we know the rest of the stuff works fine. Let's take a look at this inventory to make sure it looks good. Shiny plate armor, that's correct. Heal potion, 2 left, very good. And there's that rusty hand axe that we put into our inventory. That all looks pretty good. Let's try one last thing. What happens if we just use all these potions? Use 2 more potions. And the tricky thing about this is we need to hold this reference to it to be able to use it. So we'll probably sort that out later to be able to use things from the backpack, but we sort of need an interface to work with that, which we have not built. And then let's just do this inventory again after using potions, because what we're expecting to happen here is after it uses the last potion, it should hit this quantity equals 0, mark the item for deletion, and call cleanup backpack. So we just want to make sure cleanup backpack actually removes the items marked for deletion and we don't get any dereference errors. Okay, something failed there. What failed? Oh, it's just a redefinition. Yeah. So we probably want to isolate these. We're not declaring anything that we want to keep permanently in scope here. So let's just put these each in their own scope like that. And that should solve that problem. There's a quick hack there. So let's look at the bottom and just see that this looks correct. And it's a lot of info. Oh, we need it. Let's break a new line here. All right. So just in between these, let's just put a new line in here somewhere. That way we can tell what's going on. And it looks like we do have a bit of a problem. It is, oh no, this isn't a problem. This is actually fine. We called use potion, but after using potions, the thing is it didn't reduce their quantity. But there's a reason for that. And it's because when we call use on the potion, their health is full and it doesn't have a buff. So it doesn't actually use the potion since they're full health. So that's actually working as intended. But we can fix that. Let's just make them take like 20 damage. So they need some heals. All right, then let's do it. And it should use up the potions. Very good. Inventory after using potions. Potions are gone as intended. And as you can see, their health is further down. But after using these 2, if we spit out the health again, it should say 16. We could check that if we really wanted to. Let's just do it for the heck of it. Here we go. Put it right there. After using 2 potions. All right, so this main code is getting a bit messy. There we go. All right, but this whole item setup is actually working quite good. I know this episode is probably really long. I'm going to cut it as much as possible, but we got some important work done here. And yeah, super awesome. I hope you're learning a lot. If you're managing to follow along with this, you're probably going to learn a lot of new understanding about how pointers and memory works. And if it's still kind of puzzling you, just keep practicing with it and just do your best to wrap your head around these things. It does just take time to fully understand this, but maybe some of the times when I'm explaining it, just like listen to that a few times until it kind of clicks. But yeah, it's really important stuff to get right. And chances are we're messing up a few things here, but overall in our initial testing seems to be working fine. In next episode, I'm going to intend on turning this more into a library and building some tests, because right now we're running into the, well, it's not technically an issue, but it's odd. This main is essentially just a big test runner. It just does a bunch of things and we're just checking the output to see if it looks as we intend. But we can do better because we can actually build tests, and then we can do some test driven development where we know what we want it to do. So we write the test and then we write the code and see if it passes the test. It's going to be a great case for that because this main's getting real messy and it's turning into chaos. And then basically what we can do from there is we can actually design a real game and use all the stuff. And when we build new stuff, we can, run the tests to make sure the new stuff we're building is working correct, et cetera, et cetera. But essentially all this code is going to be put into tests, except instead of like looking at cout and seeing what is in there, we'll just do comparisons. We'll just basically say, okay, after we do this action, what are we expecting? Make some asserts and see if it passes or fails. So that way we don't need to analyze our couts and all this console code, because that gets real tedious on the eyes. It's better to just have a nice list of potion use, pass fail, inventory delete, pass fail, down the line. And that'll be a million times better. All right, don't forget to like and subscribe. This has been episode, 12? I'm kind of losing track. I'm still intending to go to episode 20, and I'm starting to kind of debate where I want to take these final episodes. So leave a comment, and if you really want to influence, I'm going to listen to the patrons and members of the channel. So if you sign up over there at any of the tiers, I'm going to be asking over there and highly considering, but also I'll look at the consensus of the general YouTube stuff. But I take most YouTube comments with a very large grain of salt, even if I can read them at all. At this point, I will say that, like, some days enough comments come in that I literally can't read them all. It would just be almost a full-time job on its own just to respond. So I'm probably going to be getting a little more picky as time goes on. I just have so many videos at this point that people comment on old ones all the time and stuff, and the queue just fills up very quickly. And if I'm not answering them right away, it stacks up huge, and there's no way I'm going to get to them all. So yeah, definitely going to be prioritizing paid supporters and stuff like that. So just an FYI, I think it's the way it's got to be in the future. All right, appreciate you guys, and hope you're learning a lot. Stay tuned for the next upcoming episode, and peace out. Happy coding.